In this video, we're going to do a basic, and I do mean basic, review of C++. You should know all this before coming into this course. But basic data types, we'll start with data handling. In C++, we have several basic data types. The most common ones seen are int, float, char, and double. Now, typically int is 2 bytes, so it may be different. Float is typically 4, but sometimes it's 8, depending on these are all implementation specific. And double is an extended float. Float is very rarely used. Most people do use double instead. There's also long instead of int for a longer int, and there's short as well. So here are some basic data types and the widths they take. Char, unsigned char, signed char, etc. all the way on down the line. And these are the basic types that we've all already seen. So from those, we have some derived data types. We have an array. Array is a data structure which allows a collective name to be given to a group of elements which all have the same type, and you access them by an index. For example, double balanced with a array size of 10. We've also used the generic arrays from STL, which you're probably more familiar with, but the concepts are the same. Similarly, vectors. Functions. A function is a group of statements that together perform a task. Every C++ function has one function called main, and all of the most trivial programs, all but the most trivial programs define functions. Pointers are something we'll get to. Reference is a reference variable like an alias. It's another name for an already existing variable. Once it's initialized, you cannot change that initialization on the reference. It's used to refer to another variable, and it acts just like that. So flow of control. By default, flow of control in a program is sequential, first step to last step, but we have some ways to alter it. We have if else, switch, the ternary operator, and we have while, do while, and for in terms of loops. We have break and exit and continue. Goto is listed here, but I'm going to pretend I didn't see it. So, if else statements. If age is greater than or equal to 18, do this. If age is less than 8, do this. If here we print major if it's 18 and minor if it's not. And here we can use an if followed by another else followed by another if followed by an else. Switch is similar. It takes an expression, and these are the possible responses, which need to be integers, or not integers, need to be well defined at least. Floats don't work well here. And you have what you're going to do, and then you have the break statement, which takes you out of the case statement. There's also default, so if none of these match, it'll go to the default. If you leave this out, it just exits. The question mark operator is a shorthand for an if-else statement. And so, for example, you have your condition, question mark, true part, colon, false part. So it allows you to do quick assignment statements. So for loops, we have several types. We've got while, which is an entry-controlled loop. While num equals 10, while it's greater than 0, in that loop, we repeat this, print out the number, subtracting 1 until it gets to 0. It only executes if num is greater than or equals 0. So if number was set to 0, it wouldn't run at all. Similarly, with a do a while, we execute until this is true, but we go through it at least once. For is just a modified loop. It has an initialization here. It has a check. It has an increment or decrement. And it has the code you actually want to run. But it is essentially the same thing as this loop right here. The num corresponds to the initialization. The expression corresponds to the expression. And the minus minus corresponds to what's happening at the bottom of the loop. So there are two common jump statements you use, and they're called jump because they change execution. We have break statements, which break you out of a loop or a switch. When the control reaches a break statement, the rest of the statements in the loop are ignored. Basically, it would jump from here to here. Continue says continue but go to the end of the iteration. So here, instead of going to the end, it would go to here. So if a equals 5, it won't print out a, but it will continue on with 6. So functions. A function is a group of statements that perform a task. Every C++ program has one called main, and that's where we start. And a function declaration tells the compiler about a function's name, return type, and parameters. This is also called a function signature. A function definition provides the actual body of the function. To use a function, you have to call or invoke that function. So if we define this function, int max 1 and 2, what defining it up here does is just declare, this declares it, and it says this function may be used below it, and then we can define it later. Okay, so here we got our function declared, here we use it, and then here we define it. Whenever functions appear before they're actually used, there's no need of a function prototype, but I would do it anyway. It's better for modular programming. So, there are two types of calls you can make with parameters. Call by reference and call by value. In call by value, a separate copy of a formal parameter is created, and values of the actual parameter are copied into it. Any changes made to the formal parameter will not affect the actual parameter. Now, unfortunately, I screwed up, and this guy is here. Here is the call by value. A is 40, B is 20. Display is sent in a copy of A and B. Okay. Oh, and here's the implementation. Sorry, I got confused there. B we pass in as a reference. So here, if we output, here we change A is 40, A equals 10, A is 50, but it's A passed by value, so it's not changed. B is passed by reference, so it will output 30, so your result should be 40 and 30. Parameters may also have default arguments, which are default arguments given to the function. By default, the number of actual parameters must match with the number of formal parameters, but if you use default arguments, there's no such restriction. Missing arguments will take default values, which means that they have to be at the end, by the way. So here, int A, int B, and int C equals 12, all of these calls will work. Call it with 3, where this way C would be 3. If you call it with just 2 values, C would be equal to 12. A structure is a collection of variables which can be the same or different types. The structure name becomes a user-defined data type and may be used the same way as other built-in types. So we define a structure by using a keyword. For example, struct student. Don't always capitalize it though. It has a roll number as an integer, an age, an array of characters called a name, and a float called marks. Student is called the structure tag, and you can use it just to declare a new structure. So you could say student, my student. You can also directly use the structure in the declaration, but again, I don't think this is as clear. Keep your definitions separate. You access data members by using the dot notation. So if we have an instance of student named S1, we can use S1.rollNumber, S1.age. You can also do a quick initialization. If you do student S2 equals, you can say 100, 17, etc., and it will assign them to each of the variables for you. It's a handy little tool. So, when you assign one structure to another, the statement assigns the value of each member of S2 to the corresponding member of S3. Now, the structure types have to match, otherwise the compiler will give you an error. You can use nested structures. For example, you can have a day structure, which we use in our student structure, although this should be spelled in lowercase. So typedef is used to define new data types from an existing type. It provides an alternative name for standard data type, and it's just to help document your code better. The general format is typedef, or typedef, existing data type, new data type. For example, typedef float as real. Now you can create a variable called real amount. Okay? And the enumerated data type defines the set of names which are stored internally as integer constants. The first name was given the integer 0, second 1, and so on. So, for example, if we define enum months, January, February, March, April, May, it's user-defined, and it works if you know, if in advance, a finite list. Now, the one thing is the list isn't input by the user or output by the user. You have to have routines to convert between the two. But here, in this case, Jan would have the value of 0, Feb would have the value of 1. Now, if you want to change the values, you can put an equal sign here. So Jan equals 1, Feb equals 2, and so forth, as long as they're integers. So there is a define preprocessor directive to define a symbolic name like pi, although we're really not going to use that very much. Every variable has a storage class and lifetime of a variable. These specifiers precede the type that they're using. There's auto, which means tell the compiler to figure out the type. So you say auto x equals 5, and it will know to figure out that x is an integer. Register is a suggestion of the compiler to put this in a register. Static means it will live across a class. There's only one instance per class. And external means it's defined and implemented elsewhere, like in another file. So, external is usually give a reference of a global variable that is visible to all. It basically makes it not initializable, but you can see it in other programs. So then we're going to talk briefly about function templates. A template is a function where you say that the types it takes are parameters. So, for example, we'll have this function template with a class type of myType, and it takes a parameter myType for its parameter, and we return if A is greater than B, return A, otherwise B, and as long as greater than is defined, this will work, and it takes these values and infers them and says to these, instead of this being myType, use integer, in this case use float, etc., and it generates duplicates of them. So when an int is used as an argument, myType looks like an int, and a float is using, myType looks like a float. What's required for this to work is that the greater than operation must be defined. So that's the quick overview of C++. There's obviously more to it, but the rest we will be reviewing, particularly classes, the rest we will be reviewing as we go on through the rest of the topics.